As I told you later, as I told you earlier, I said I'm going to discuss two applications, and in fact I've discussed the first application in the previous video. Now I'm going to discuss the second application. That is where we find the gradient function, the nature of the turning point, and the turning point of the curve. That is what we want to deal with now. Now, if you look here, I have a question. The question says the equation of a curve is given as y is equal to a 30x cubed minus 4x plus 5. Determine the value of y when x is equal to 3. Now, you have an equation saying that y is equal to a third x cubed minus 4x plus 5. Then you want to find the value of y when x is equal to 3. When x is equal to 3. Now what do? I substitute the value of x into the equation. Substitute the value of x into the equation. Now you find that y is equal to a third, then 3 cubed. A third times 3 cubed. A third into 3 cubed minus 4 times 3 plus 5. What do I find there? A third into 3 cubed, that is 3 cubed is 27. The third of 27 is 9. Now you find that is 9 minus 12 plus 5. Then 9 plus 5, that is 14 minus 12 is 2. Now you find that the value of y when x is equal to 3 is 2. Then the next one is that you gradient of the curve when x is equal to 3. The gradient of the curve when x is equal to 3. What do I find? Because the gradient of the curve, we find something called the gradient function. Because to find the gradient of the curve, you know, a curve is something which looks like this. And a curve, you cannot find the gradient, or you cannot find the gradient unless you find its gradient at a point. You see, at a point. Now that the gradient of a curve at a given point, you find that gradient. Now they want the gradient of a curve at a point. And when you get the gradient of a curve at a point, you get something called the gradient function. And the gradient function is always the differentiation of the original equation of the curve. Is the differentiation of the original equation of the curve. And if you look at the original equation of the curve, the original equation of the curve is saying that y is equal to a third x cubed minus 4x plus 5. Then to get the gradient function, we differentiate this one here. Now gradient function is equal to differentiation of this. What is that? That is 3 times a third, that is 1. That is now x. It means just x squared, then minus 4. Now this is the gradient function. Now I want to find the gradient. We just put the value of x given, which is 3, to this gradient function to get the gradient. Now the x cubed, the x squared, that is 9 minus 4. What is that? 5. Now you find the gradient of that curve is 5 when x is equal to what? When x is equal to 3. That's the gradient function. The gradient function of that curve. The gradient function of the curve is a differentiation. Then we find the gradient. Finding the gradient, we put the value of x, the value of that point x, to the gradient function. That we get the gradient. Then the next thing, we get the turning point of a curve and its nature. And it is the point of concern. Mostly this is the point of concern. How do we get the turning point of a curve? The turning point, as you know, that a point in the form of x, y. Now the turning point, a turning point of a curve, the gradient function at the turning point of a curve is always 0. That means the gradient at the turning point, a turning point of a curve, the gradient is always 0. Now that means the gradient function must be equated to 0 to find the turning point of the curve. Then having equated the gradient function to 0, like x, equating the gradient function to 0, that is x squared minus 4 equated to 0. I find the value of x, I take that for the other side. I say x squared is equal to 4. Then you find the square root both sides. You find that x is equal to 4 or negative, 2. X is equal to 2. The root of 4 is 2. 2 or negative 2. X is equal to 2 or negative 2. Now, how do I come with negative 2 or 2? How? You know that when you square negative 2, you will get When you square negative 2, you will get 4. When you square 2, you will get 4. Now that means the square root of 4 can be negative 2 or 2. The square root of 4 can be negative 2 or 2. Now the turning point of this curve is at 2 and negative 2. That is the turning point. That is, the value of x at the turning point. Now, because the turning point it can be said to be a turning point, can be said to be a coordinate form in form of x, y, I must find y. And to find y, I replace the value of x, the value of the first x, into the original equation to get y. Now, the value of first x, the value of x, the value of first x is 2. Now, I take this 2, I place here to get y. I place it here in the original equation to get what? To get y. Now, 2y is equal to a third into 2 cubed minus 4 into 2 plus 5. Or the next one is y is equal to a third into negative 2 cubed minus 4 into negative 2 minus plus 5. You find that? Now, let's find this value of x. Let's find this value of x. With this one, this is 2 and a third. That's 2 and a third. 8. 2 cubed is 8. Now I can say 8 times a third. What is that? 8 times a third, that is 2 and a third. Now I find this one, 2 and 2 thirds. I find 2 and 2 over 3. Negative 4 times 2, that is negative 8. That's minus 8 plus 5 plus 5. Now, 2 and 2 over 3, answer minus 8. Answer minus 8 plus 5. What is that? I find it is negative a third. Then, now y there is negative a third. Y there is negative a third. That is negative 2 and 2. That is 2 and 2 thirds minus 8 plus 5. That is negative a third. That's negative a third. Then when I come here, I can say that is negative 2 and 2 thirds plus, that is plus 8 plus 5. Negative 2 and 2 thirds plus 8 plus 5. Negative 2 and 2 thirds. We'll put in this into proper, that is 6, 7. That's negative 7 over 3 plus 8 plus 5. Negative 7 over 3 plus 8 plus 5. Or negative 7 over 3 plus 8 plus 5. Now negative 7 over 3 plus 8 plus 5. I find that one to be 10 over 23. Now find that one to be 10 and 2 over 3. Not 10 over 23. It is 10 and 2 over 3. Now these are the values of x. This is the value of x when y. That's the value of y. This is the value of y when x is negative 2. And this is the value of y when x is 2. Now the turning point is in form of xy. Now when the x is 2, y is negative a third. And when x is negative 2, y is 10 and 2 over 3. 10 and 2 over 3. Now these are the two turning points. These are now the 2 turning points. Now I want to find the nature. of this turning point. This is the first question. Get the turning point. These are the turning points. Now I want to find the nature of the turning points. Nature and of the turning points. Now there are 3 nature of the turning points. Number 1, we have upper turning point. Then we have lower turning point. Then we have point of inflation. inflection. Point of inflection. Wow, how are these points moved? Now, when you have a zero, now at a turning point, it is zero gradient, and a zero gradient line looks this way. Zero gradient line looks this way. Then the upper turning point, you must have something which looks upper. Now, if you look at this line, its gradient is positive, and this one, the gradient is negative, and this one is 0. At the lower turning point, you find it looks this way. It looks this way. That means this one is positive, this one is negative, and this is 0. At a point of inflation, it goes this way, or this way, or this way. Now, it can be at a point of inflation, it can be a negative 0 negative or positive 0 positive, the gradients. Now, to find the nature of the gradient, of the nature of the turning point, we must have a sketch. And how do we have a sketch? We consider the value of x, because we have the two turning points. Now we want to know the nature of each and every turning point. We consider the value of x. Now you put the first turning point having 2 at the center, as the gradient, which is 0. Then you move backward of the 2, that is what? 1. You move forward of the 2, that is 3. Now we find that that's the value of x. Then you find the gradient. Then you find the presentation of that gradient. You find the gradient and you find the presentation of that gradient, how that gradient moves. Then the next one, the next turning point, we're having the value of x, gradient, and the presentation. Now, at this point, the value of x is at the turning point where the gradient is 0 is negative 2. Now, you move backward, you find negative 3 there. Then you move forward, you find negative 1. You find negative 1. Now, we want to find the gradient of each and every point at this point. We want to find the gradient of each and every point at this point. Now, the gradient when it is and you know the gradient function. The gradient function we got is x squared minus 4. Now, we want to find the gradient function. We want to find the gradient using this gradient function and the points we've gotten here. We want to find those gradient. The gradient. Now, we take this one. The value at this one here. In fact, this one is 0. The gradient function there is 0, and it is a straight line. Then here is also 0, and it is a straight line. Now we want to find this one and this one. What is this? We want to know whether it is a positive or negative. We want to know if it is a positive or negative. We want to know this is a positive or negative. This one a positive or negative. Now what do? Take this one, place it here. What do we find? We find that it is x squared. X squared, 1 squared is 1 minus 4. 1 minus 4, negative 3. 1 minus 4 is negative 3. Then this one here, place it here. That is 9. 9 minus 4 is 5, positive 5. Now this is a positive 5. Positive 5. If a negative gradient goes this way, a positive gradient goes this way. Now you'll find that it is something which looks like this. What is that point? This point is called the lower turning point. The lower turning point. Now, point 2 negative a third, 0.2 negative a third is lower turning point. Then we go to point negative 2, 10, and 2 over 3. This point here. This point here, we find, you now put this one into the equation. Now look at this one here. When you place that, that will be 9. Then 9 minus 4 is 5. That is positive 5. Then this one here, place it there. That is 1. 1 minus, that is negative 3. Then now this is a positive gradient, 0. Then a negative gradient. Now if you look at this thing, it becomes this way, goes this way, then comes back this way. That is now the upper turning point. Upper turning point. Now, and that is the end of what I wanted to present. Now you've seen the application. You've seen the application in the turning point of a curve, the gradient function, turning point of a curve, and the gradient of a curve at a point. Then this one here. Sorry. I find Okay, this one here is a previous video which has been uploaded previously. It is the application of differentiation in kinematics. Thank you very much. Thank you very much. If you have viewed my video, please subscribe to my video. It is very essential for those who are going to sit for their exams. Very essential. Now, subscribe to my channel, like it, and if possible share my channel so that everyone might get the information and they follow the videos for revision. Thank you very much. Have a nice day, morning, or night.